In the demo that we just went through, you saw data moving back and forth between, say, integers and doubles, doubles and integers, integers and booleans, characters, back and forth around from type to type. Yes, we wrapped up with an overflow, but not all type conversions involve overflows or loss of data or are somehow bad. In fact, taking data in a variable of one type and putting it in another type is a very common thing to do in C++, and the compiler will take care of the conversion if the types are compatible. Sometimes it will just have nothing to say about the whole process. You have an integer, you want to put it in a double, no big deal. It will promote the integer value to a double value and put that new promoted double value into your variable. If what you're doing could cause a loss of data, the compiler will give you a warning. If the types are completely incompatible, like a double quoted string trying to be put into a character, then the compiler will give you an error and the application won't run. Once you have it compiled and all you have is warnings, you're not going to get runtime errors as you move things around from one type to another. That stuff is taken care of at compile time, and there are not checks at runtime. That's a performance feature. Now this means that you mustn't ignore compiler warnings. Some compiler warnings are telling you about serious possible bugs, like throwing away all of the decimal places in your floating point number when you put it into an integer. The problem is if you have a large project, you have normally 307 warnings. You might not notice that this morning you have 308 warnings, and you really need to go and look at the new one because it's a bug waiting to happen. The solution to this, of course, is don't have 307 warnings. There's a mechanism called casting that lets you tell the compiler, I know what I'm doing here. This is my choice. I know I don't have an integer, but I want you to turn it into an integer and then put that newly made integer into my variable. Then there will be no more warning, and it's clear to anyone who's reading your code what it is you're trying to do. Now, can this be dangerous? Of course it can. If that's a double with points of information in it that you needed to keep and you cast it to an integer and throw them away, nobody's going to stop you. C++, the saying goes, makes it easy to shoot your foot off. And the compiler, when you cast, basically says, well, okay, it's your foot. You know, you're asserting that you know what you're doing. I'm going to believe that you know what you're doing. These traditional casts, which are sometimes called C-style casts, are not the absolute best practice. After we've gone through templates in this material, I can show you some safer and better casts. But for now, I'm going to go through traditional C-style casts, which basically tell the compiler, back off, I know what I'm doing. And while we're talking about converting types back and forth, I also want to show you the suffixes that you'll occasionally see on numbers, and they're only allowed on numbers, to indicate the type of a literal. So a literal is a number like 0 or 1 or 2.2, and these suffixes can say, I'm telling you that this is a long, or I'm telling you that this is a float. And that's done as a form of casting to say, I would like to take a long 0 and put it in here, as opposed to a default integer 0. There's not a lot of compelling reasons why someone getting started in C++ would care what size of 0 they put into a number. But when you read it in someone else's code, it can just kind of stop you in your tracks and you say, what the heck is 0L? So I want you to see it so that you recognize it when you bump into it.